And welcome back. I'll now like to introduce our next speaker, Heidi Waterhouse. She'll be talking about resiliency, harm reduction, over-engineering, and planning for future. Take it away, Heidi.
So what we're going to talk today about is what a disappointing disaster is, how something can go wrong and yet not be catastrophic. So imagine this. There is a young sysadmin who works in Iowa doing things with literal farm equipment and also some servers. And it is December of 1999. And the thing that is about to happen is the Y2K rollover.
And the thing that's not about to happen is she's not about to lose her job because she needs it. But she wants to go ahead and go to the Twin Cities for her big Y2K party. And so she says, okay, boss, I have upgraded all of the things. I have patched all of the things. Everything is going to be fine. And he said, well, how do you know that if you're not going to be there? And I have a question for you. How many of you have been on call? And then how many of you had an actual pager? And I didn't put this on there, but if you had an actual pager, how many times did it fall off your belt into the toilet? Because that was a thing that happened to people that I knew. This was an actual pager, and when Pagey from PagerDuty comes on with little arms and legs and is all cute, you have to understand that some of us have like a visceral reaction to the idea of a pager, because when you got paged, it wasn't like you opened your phone up and asked what was the matter, or like hit your observability monitoring stuff from where you were in the loud nightclub. No, it meant you had to go hang on a payphone outside the nightclub, hoping you had enough quarters so that you could figure out whether or not you needed to actually go into work. So when we were talking about what was going to happen at Y2K, it was this real feeling that you had to be in the room where it happened in order to make everything work. So we were all ready for the big night. There had been things patched that had never intended to be patched, like some monkey wiring to patch in a 3.5-inch disk drive to telephony. That was happening all over the place. That was how it worked. And this was a vital job. And I left this slide in because it makes me laugh, because it turns out this has always been a vital job. It will continue to be a vital job. And you know why we're using COBOL and not something modern? Because modern languages are not good at math. And if what you're dealing with is people's money or spaceships, you would like them to be really, really good at math. So we are never going to get rid of COBOL because it does what it does better than anything else. If you want to take up COBOL programming, more power to you. I will never laugh at you. And yet, as I go around giving this talk and talking about Y2K, which was sort of the start of my tech career, I have this problem where a lot of people who are legitimate senior engineers didn't live through it. They didn't have this experience. They didn't spend the hours and days and months in 1999 and 1998 and 1997 mitigating what we knew was going to come. And now that we're through it and nobody remembers that work because they weren't the ones doing it, it's really easy to say, oh, well, we over-prepared for that. I think that's a lot of how the human mind works. Either something was so terrible, how could we have not seen it coming and done something to make it better, or it couldn't have been that bad. But we are really bad at recognizing when we do take the correct proactive steps to make something better and it works. We're really bad at that. I think I want you all to remember that when we start talking about having conferences in person again and going outside and getting haircuts, that it's going to hopefully seem like we blew this out of proportion. And what that actually means is that we did the right thing, that we got it right-ish. Because if this all seems like it was an overreaction, then we did our jobs. So how do you keep disasters from happening? There's two main categories to this. First is risk reduction. Risk reduction is How can we prevent bad things from happening in the first place? Stay-at-home orders, vaccination, train gates, anti-lock brakes. These are all examples of things that we are doing individually and collectively to prevent bad outcomes. How do you reduce risk? So I've told you some examples of risk reduction, but how do you reduce risk? How do you, in your own environment and the things that you control, reduce risk? The first thing you need to do is secure your zone. This is one of the things they tell us when we do counseling for anxiety, is to figure out what it is you can control and what it is you can't control, and keep those in separate lists. So I worry about a lot of things, but I can only work on the things that are under my control. So you have to be able to secure your zone. If what you are worried about is downtime, the first thing you have to do is secure your environment. And the second thing you have to do is make sure that all of your providers are secure. But until you've secured your own stuff, you can't really make a valid case for, I need you to do work to make me safer. First, you have to make yourself as safe as you can. One of the examples I use for this is, for a while, I had commit rights to LaunchDarkly's repository because I was helping with the API documentation, and it was an integral part of everything, and we didn't have very fine-grained controls that early on. And so in order to keep me from doing something drastic that broke the code, we had a backup where someone always checks a pull review. And that's really automatic and easy, and something that we all do as a best practice, I hope. But what it's doing is saying, okay, the risk is Heidi will commit something that breaks the code. Let's reduce that risk by making sure Heidi never commits anything without a second set of eyes. That's how we do risk reduction. We build in fail-safes. We build in safety rails. Another useful way to do this is to be able to predict states. We want to know all of the states that something can get into. And when you start thinking about state machines as a way to predict the future, you start to realize how little you actually understand about your system. Like, how many ways can you break? Somebody said, as a spin on a Chekhov quote, like, every happy path is the same happy path, but every unhappy path is very different. I really loved that as a testing mantra. Like, every unhappy path is different, but you can certainly say, I expect my code to end up in one of these states. Here are the things that get it to that. Now that I have a map of how my application behaves, I can logically derive what's going on. But even though we want to reduce risk, we can't entirely eliminate it, because if we stopped moving forever, we would never get anywhere. This is the tension between safety and advancement and progress. So you have to accept some risk. You can't prevent everything. You have to decide what matters to you to save. What is actually important? What is key data? If you can't afford to store all of your data, and very few of us can, make mindful trade-offs based on what you've needed in the past and what you might need in the future, and say, okay, maybe I'll initiate auto-purging for stuff that's older than this because I've never had to look back more than 6 months for a problem. If there's going to be a problem, it's going to be in 6 months. Everything after that, we're just going to purge. So once you've accepted risk, then what you want to do is harm mitigation, because you know that bad things are going to happen eventually. Like, even a car with anti-lock brakes will sometimes get in an accident. Even somebody who is staying home will sometimes be exposed to someone who hasn't been staying home. How do we mitigate harms that we can see coming and the ones that we can't? Well, let's talk about what happens when things go wrong. Let's make a plan for our unhappy paths. These are two tower fires. One of them killed hundreds of people, and one of them didn't. They both have the same aluminum cladding, but in the UK, the fire law is different. I notice this every time I'm there, Australia too. They don't have the cultural scarring about exits that open out. The Triangle Shirtwaist Factory, in addition to being a milestone of the labor movement, that fire was also searing for the American imagination because we saw all of these people piled in front of doors. And it's a fire safety thing so ingrained in American architecture that we never think about it. But if you are in a public building and you want to get out, all of the doors will open out. If there is a stampede, all of the doors will open out and nobody will get crushed up against the doors because they couldn't open it because of people behind them. In Grenfell Tower, that was not the standard. They had one exit stairway instead of the four at the tower that everybody survived. And when it got blocked, there was no alternative exit. So nobody wants their skyscraper to catch fire. That's terrible. People die. But some designers, some architects, some policy wonks have made it so that if the unimaginable happens, then people can still get out. There were 3 injuries in the taller tower fire in Dubai because there were enough exits for everybody. And that's what I want us to be thinking about when we're designing software. How can we keep everybody safe? That's the first thing. Like, I don't want to make anything that makes people unsafe. I don't want to make anything that makes people take risks unthinkingly. I don't want to have default behaviors that put people in peril. And I realize that seems like a little overblown for a lot of us who are making software tools, but our software tools make the software that people live with. And if we don't take responsibility for our part of the chain, why should we expect consumer-facing people to take any responsibility? So how do you mitigate harm? How do you make it so that when bad things happen, they aren't terrible? Well, first, you need to decide if you fail safe or fail secure. What is it you are protecting? What is the most important thing to you? And what are your risk factors? Many, many years ago, I worked on the first iteration of Windows BitLocker. And it was a revolutionary product because we assumed that it was better to brick a hard drive irretrievably than to lose the data that was on it. In the cloud era, this seems like such a gimme. Our laptops are sort of disposable portals to the cloud where we have actually stored everything important. But in 2003, 2004, 2005, this was a radical thought that the risk of exposing the data was more than the $2,000 to replace the computer, or even the lost time and energy that an engineer or a C-suite person had put into the other things on that computer. We decided that people had to be able to make the choice to trash all of their data rather than expose it. And that was a new and sort of scary choice. But we have a lot of these choices built into IT in a lot of places, and we don't really think about it or talk about it. Like, if you are an old, what was the phrase, server hugger, did you ever work in a server room that had halon that would drop inert gas if the servers caught on fire to protect the servers? There was a mask in the room, and you should have a little time to get out. So probably you weren't going to die. But what they were saying is the small risk of death to the operator is something we are willing to trade for these servers. That's kind of amazing, like, to make it explicit like that. Like, we're going to try and mitigate the risk of them dying, but this data is more important than a fractional human life. Wow. So you need to sit down and think about what you're protecting. Because failure is inevitable. We are humans, we work in fallible systems, we have bad days, we have viruses, we have small children climbing on our laps, a cat may launch the spaceship. Like, failures are going to happen, but disasters are not inevitable. Disasters are a concatenation of failures. It is never just one thing that makes a disaster. There is no one disaster. So what is a disaster if I'm saying it's not just one thing? I'm from Minneapolis, and this bridge was an interstate bridge that used to go across 35W. It doesn't anymore because it fell into the river one fine summer day, completely to the surprise of pretty much everyone. nobody had expected it. Nobody had thought, I wonder if that bridge will fall into the river. But here's what happened. The Army Corps of Engineers dragged it out of the river and spent a lot of time analyzing it. And they said, okay, so here's the deal. The trusses, those rivet plates that you see that are buckled, were half as thick as they should have been, as they were spec'd to be. Okay, that's not great, but is that what caused the failure? No, because the bridge had stood for 60 years with the substandard trusses. You see some rust there. Was it corrosion? No, it didn't help, but it definitely didn't cause it. We'd been doing resurfacing on the road, and so there was an extra, like 20 tons of material plus several dozen tons of equipment on the bridge. That didn't help. But we'd done resurfacing before, and it hadn't fallen into the river. It wasn't any of those things exactly. It was all of those things. If there hadn't been construction, the trusses would have held. If the trusses had been thick enough, the construction wouldn't have bothered them. If there hadn't been a vibration that set up some kind of resonance, it probably would have been better. But none of those things individually had ever caused that bridge to fail. Only when you brought them all together at the right time did you actually get a disaster. All of these little failures, all of the I didn't put the thing to spec, all of the I didn't think about the extra load on the bridge, none of those mattered until they all mattered. So we talked earlier today about Simi and Army and how Netflix did this, and Gremlin is sponsoring this conference, and they are all here to help you inject a little chaos into your life. And what we're saying is, we want you to not just find the place where the chaos injection, the failure injection, fails in a predictable way. We want to find the place where adding enough noise to your system causes other things to fall over. Because that's the only way we're going to be able to test these systems. Our systems have what I heard someone call dark debt. That is not technical debt, like debt that we know we're taking on, like, oh, we're going to have to rewrite this eventually. That's an acknowledged debt. No, what we have is dark debt that we don't know we're taking on because of the interconnections of our systems. Because nobody is writing software in isolation. We're all consuming packages. We're all using each other's tools. We're all interconnected. And so even if we are doing it right, we still have to allow for there to be failures in our stuff and in other people's stuff, and allow those to interconnect with each other, to interplay with each other. Like, I think it's really interesting. Every time you dig into somebody's post-event analysis, it says, it was all going fine until the last thing. And J. Paul Reed is going to tell you, and everybody else has told you, the last thing is not what caused the problem. It's all the other straws on the camel's back. The last thing is just one straw. If you had put it on first, it wouldn't have been the last thing. So we need to be able to design for how that works. So here are things that make disasters fizzle. Here are things that you can put into your designs to make things go better. Not necessarily right, but better. And I usually have this slide in here so people can take pictures of it, but we're going to go through it. So microservices and loose coupling. If things don't actually depend on each other to run, that's going to work better. I was just talking to Jason, who was showing off his mic that has basically rubber bands that hold it, so that when he touches his desktop, you can't hear it in vibration through the mic. That's the kind of loose coupling that we need in our systems. They need to be able to flex a little bit, take some unexpected hits, have a little like spike in request without freaking out. Fault-tolerant messaging. It is truly said that the internet routes around censorship as if it were damage. And that's because the internet was designed to take damage. It was designed for nuclear war. And so we had to assume that at some point, somebody was going to take out part of California or Illinois, something. We didn't know. But the whole system, everything about the structure that we're building on, is designed so that you can route around damage automatically. fault-tolerant messaging is the way to route around your internal problems. So if you have a database down, and that's also doing your error catching, how do you know your database is down? Right? It's a real problem. Data duplication. It's not a backup if you haven't tested restoration. My friend was at a conference for Pure Storage, or a talk, and they were talking about how people are now doing ransomware on backups. And if you don't have your backup vendor checking to make sure that there aren't a lot of injections that are basically malicious encryption, then how do you know that your backup is going to work if you get hit with ransomware? Like, this is a really cunning attack, and I'm impressed by it and also a little bit horrified because I don't think we're ready for that one yet. But I think we've all had that moment where we're like, oh, everything went terribly. I really need to go back and do a restore. And then your restore doesn't work for whatever reason. Canary launches. We want to be verifying in production, live, with the full weirdness of everything that people do as users, that what we're building is going to work. And if we don't have that, then we're not going to know where the problems are when we do a full rollout. So a small launch is going to give you a lot of intelligence on how a big launch is going to go. Kill switches and circuit breakers. This is an automation thing. I want you to automate your system so that it protects itself. I want to have essentially the software equivalent of, if a kid sticks a fork in a socket, what happens is the circuit breaker trips and we don't fry a child. I would rather have all sorts of like back-end shutdown happen rather than have the bad action happen. So you need to be building in kill switches and circuit breakers, and humans are the squishy and slow responding part of any system. So when you're building these in, you need to automate them, because this is the time you're thinking about what's going to happen and how to make it better. And let's try automatic recovery. Like, I would love to say that in the modern world, you can't fix everything by just rebooting. But I have to tell you that, as near as I can tell, you can fix a lot of things by just rebooting. So maybe the first thing that happens when you detect an error state in your system is that you reboot them. And of course, you don't want to have this stuck in a boot loop. You want to have it like one and done. But you do want to give your systems a chance to sort of recover themselves and recombobulate, maybe even before they page you. Maybe they could be like, hey, yeah, no, I had indigestion last night and I rebooted myself and I'm feeling okay, but if you want to look into it today, now that you're rested, that seems great. We already said this too, test for load and stress and outage. You have to be testing for internet scale, even if you don't think you're going to need it yet. Back in the dawn of time, we had this site called Slashdot, and it was a news aggregator, sort of like Reddit, only everybody read it. And what would happen is a small site, like an indie comic site or something, would get Slashdotted, and half the internet would descend on them to see the cool thing. And of course, before we had elastic scaling, it was like sometimes people's sites were running off, you know, a box under their desk. And so the box would get all of these demands and just fall over. I'm like, oh, I've been Slashdotted, okay. And that was then, and this is now. So when we're doing testing, I want to say, if you need to do synthetic users, if you need to do synthetic traffic, if you want to do like percentages, I don't care how you do it, but you need to test that you're actually going to be okay under load. So if this whole thing was too long and you read Twitter instead, or your work email because it's right there on your laptop, right? Here's what I want you to take away. Expect that failures will happen. They're going to. Make your systems less rigid, because a rigid system breaks faster than a flexible system. Plan for disasters, because even if you are not right about exactly what will happen, you are going to be further ahead than if you didn't plan for anything. And degrade your performance gracefully. Don't be all or nothing about what you deliver. Maybe all you can deliver is the plain text. Well, have you ever tried looking at your site as plain text? You need to be able to degrade gracefully and make sure that you are still delivering the core business value to the people that you're trying to reach. if you would like a t-shirt, I have a link here for you. And I think I have a couple minutes for questions.
That is correct. We have now opened up the Q&A. Feel free to submit any questions on Big Marker and we'll be able to answer them live. That was a great presentation, Heidi, by the way. And I'm now also very excited to possibly go get a Launch Darkly shirt.
They're very soft.
Yes, I've seen you wearing them around conferences. So I think it's definitely time for me to finally have one.
Yeah,
we have the first question that just came in. Andrew Harris asked, do you have some examples of kill switches and circuit breakers that you've implemented?
All right. So one of my favorite circuit breaker patterns is what I call the shut up API. So we had a customer who had a problem with Pinterest. If you haven't dealt with the back end of Pinterest, they're not very respectful about robots.txt, and they're not very respectful about your bandwidth. And so if you get listed on something on Pinterest, it will just incessantly ping your servers over and over and over again, really a lot, loudly. So this customer is set up, they did not call it the shut up Pinterest flag, but like this is my personal take on it, to rate limit inbound API requests, but only from the Pinterest API. They didn't limit anybody else's, but they're like, okay, we're turning you down. So if, we'll do a little rule analysis. If it's coming in from anything not Pinterest, go right through. If it's coming from Pinterest, you're rate limited, you only get it was like 10 a second was the limited amount. And so that really reduced a ton of strain on their database because they weren't getting all these API requests.
That definitely is like a great example one. It's all about handling those edge cases, being able to think about what happens when one of my dependencies goes down. We have time for one more question. Mike Stemi asks, how would you recommend testing restoration of backups in a production environment?
That's a really good question. How do I recommend testing backup restoration in a production environment? Ideally, you have all the money in the world and you set up a blue-green environment and you restore to that and then you cut over. That's not really practical for most of us unless we're actually Amazon. But one of the things that you can do is you can do a partial restoration to check the data integrity. So you can say, okay, this is production, but we're going to gate it off so that no users can see it. But we're still going to say, okay, now restore, this database or the other one. The thing you want to be careful with when you're doing that is that you are not accidentally restoring PII to someplace that's exposed. You have all of these controls on PII in production live, but are those controls still valid when you're doing a restore from backup? Because I've seen cases where people are like, well, the backup's very flat and the controls don't really apply to all of the backup data because it's, just all one big mess. And so then people were like, well, I see your social security number.
Ooh.
Yeah.
That's definitely a big part of it. And I will definitely add, it's by being able to run those dry runs of it, being able to run fire drills, that's how you actually know that you're definitely ready. I know that there are some more questions coming in, but we're running short on time. So now we're going to switch it over to those questions are going to be part of Heidi's Q&A channel.
Yep. I will meet you all there.
Thank you very much, Heidi, for this amazing presentation. Make sure to join her in her Q&A channel to continue this amazing conversation.